to align the nozzle of the machine with the sprue bush, right?
Okay.
Okay, and now what is this? At the back side I'm using locating ring again, and here this is the center hole. So what is this? Tell me. Tell me.
Which one, sir?
This.
Backplate.
Okay, so here this is the back plate, I know, but I am asking that what is the purpose of this hole? So basically there is a shaft here, right? There is a shaft here, okay? So this shaft will be attached with this back plate. Okay, so this shaft is responsible to provide the force to this plate, right? And this plate, this two plate is responsible to eject the component, right?
Already we provided the block, right? Both sides. So why we need at center?
1 minute. Where is the block? This
So
block?
both ends. Yeah.
This is providing the proper motion to the ejector grade.
Okay.
See, because there should be there should not be deflection into this because this two plate required the support, right? That's why it is nothing but it is like a support block.
Okay. Okay.
Okay, that's why. Okay, understood. So this basically there is a fitment between this and this, which is the S7 and the J6, right? And this is hole which is for the ejector. You can say that ejector rod. Okay, so ejector rod which is connected with the ejector grid, and ejector rod is the part of the injection molding machine, right? Injection molding machine, understood?
Yes, sir.
Okay, see, now again, now tell me what is this which is, tell me again, what is this? Another pin, which is connected with the ejector grid, it also have a collar. Let me transparent this. So I am just explaining the complete mold base right now. Okay,
Okay.
complete mold base. See, this is the collar. What is this? What is the purpose of this? This is nothing but this is the return pin. Return pin.
Okay.
Okay, because of this return pin, this ejector grade will get the home position again after the completion of shot, right?
Okay.
Understood?
Yes.
See, and this is the 4. Take the chamfer. See. Okay. See. Okay. So this is nothing but this is the multi-cavity. This is the simple type of component. Okay, there is no complexity into this component. This is a flat line or flat parting line surface component. Okay, so you can easily prepare a multi-cavity mold for this type of component. Is it clear?
Yes, sir.
So in this multi-cavity mold, I have covered the complete mold base components or the parts. You can say that. Including the core and cavity inside, like a return pin, like a support block, ejector plate, ejector back plate, guide plate, the guide bush, right? Everything I have covered. Okay. Okay. So you can prepare the multi-cavity mold right now. Okay, with the complete calculation. Is it clear? Now one more thing is that, like for example, if you have prepared the complete mold, and after the trial, you will get your component in physical form, right? Or customer says that, sir, there is the defect into this component, right? So because that type of defect, sometimes we have to use the air vent. We have to use the air vents. Okay. So what is the air vent? Tell me first of all.
Releases the hot air inside the cavity.
We have discussed the molding defects also, right?
Correct.
Okay. So here, wide defect in the plastic molding process. For example, this is the material. Okay, if we are filling the material into the impression, so basically because of the trapped air, because of trapped air, there is a defect. Because of that trapped air, there is a defect which is also known as voids. Okay, voids. So void occurring during the cooling while the part inside or outside the mold. है ना? Usually, you can say that thickest section of the part. है ना? Voids will be occur on the thickest section of the part, right? Is it clear? Okay, see, this is the voids. Bubbles, you can say that. See. Okay, so this type of defect can be occur into the component. Okay, this is the burn mark. So burn mark, okay, because of the trapped air, this is the one of the molding defect. Okay, can be produced by the trapped air, burn mark. What is the air vent? What is the air vent? So air vent is nothing but it is the space into the cavity section, right? So generally if we are designing the air vent into the mold, so basically we have to machine into the cavity side. Okay. Okay. So basically, what is the purpose of air vent? To escape the air from the mold. Is it clear? Yes. Which is produced by the molten plastic. Okay. So mold venting or the mold vent is usually located on the cavity side. As I told you, this is very important point. Okay. At the cavity side. Hai na? Is it clear? Okay. And around the cavity or at the far end of the melt flow to help air out of the mold cavity. Is it clear? See here. Like this. For example, this is the gate. So it should be away from the gate. Or at the opposite side. See. Okay. So here you can see that. For example, this is the what is this? This white portion is. This is the primary vent. Or here this is the secondary vent. Is it clear? See, why need air vent again? For avoid voids and the burn marks from the molded component, and for the quality plastic part we need air vent. Okay, here see the basic parameter of the air vent. How to design? See, this is the component here. Okay, here this is the top view, or this is the section view, you can say that, or the side view, you can say that. Section view you can consider. See here. Here this is the primary vent width. Okay, this is the primary vent depth. This is secondary vent. Okay. Okay. Here in this diagram showing the depth. Is it clear? Okay. Just combine this portion. See. So usually we can take a width of the primary vent around 2 to 5 mm. Okay. And if I'm talking about the depth of the primary vent, so we can take 2 micron to 20 micron, but usually it is depending upon the plastic material which we are using for the component, right? And if I am talking about the plastic material, so what is the meaning of that? Property of the plastic, right? Understood? So in previous lecture or when we are discussing about the runner or the gate, so what property we have covered at that time? Viscosity. Right or wrong? Vijay, viscosity we have covered, right? So this is the main property. Depending upon that, we have to choose the primary vent depth. Understood or not? Understood? Or for the secondary vent, I can take 0.2 to 0.5 mm. Okay. Now see here. See. Understood? The vent location should be on cavity side again. Again I am telling you, vent should be on thickest section or the opposite side of the gate location. Is it clear? Always. For example, this is the component we have. See here. This is the component we have. Here you can see that this is the gate location, and here this is the vent. This is the vent. This is the vent. See? Always should be on opposite side. Is it clear? Okay. The air vent depth is depending upon the plastic material. If I am if I'm taking the air vent depth, so what is the meaning of air vent depth? So basically I'm selecting the depth for the primary vent. Is it clear or not? Okay, so it is depending upon the viscosity as I told you. है ना? See, just for an example, primary vent, so basically we have to deal with the only primary vent. है ना? Secondary vent we can take 0.2 to 0.5 mm. It means 200 micron to 500 micron for the secondary vent. But we have to select only primary vent depth. Is it clear or not? Acha, understood or not? See, dimension, primary vent. For the ABS, just for an example, ABS, I can take 25 to 38 micron for the primary vent. Okay, how much? 25 to 38 micron. For the PC, I can take 38 to 68 micron, means 40 to 70 micron. Is it clear? For the PP material, I can take 13 to 30 micron. Or for the PVC, I can take 13 to 20. it is also depending upon the some other property of the material also, right? Acha, you understood or not? Just for an example, for example, customer said that we will use PP material into the mold. Okay, but we have prepared the mold depending upon the PC material. So what defect can be produced there? Tell me. Tell me. Just for an example, if customer says that sir, we are using PC material for making the component. Okay, so instead of the PC material, they are using PP material. Then what defect can be produced because of this change? Tell me. Vijay. Vijay, tell me. Varush. My voice clear or not? Varush and Vijay, my voice is clear or not? Tell me. Vijay. Varush, my voice is clear?
Yes, sir.
Okay, what I'm asking?
Sorry, actually I lost internet, so that's why.
Okay. For example, I have a PC material, है ना? And I have PP material also. A customer said that, sir, we will use the PC material for making the component. But instead of the PC material, they are using PP material. Then, because of this change, what will happen there? Tell me.
There will be a dimension.
No.
Sorry, I didn't get it.
See, for example, primary vent for the PC is the 38 to 68. So basically, for example, we have prepared the mold. We have prepared the mold depending upon the PC material, right or wrong?
Yes.
Okay. So we have designed the air vent around 50 micron for the primary vent. But instead of the PC, customer use PP material. So what is the meaning of that? If they are using PP material and PP required 30 to 30 micron, 13 to 30 micron air vent, and we have provided the 50 micron. So what is the meaning of that? Flashes will be there.
Definitely.
Flashes will be there, right? So because of the material change, there will be the defect. Understood?
Yes.
Okay, so that's why we have to choose the air vent depth depending upon the material. Or that's why in first or second lecture we have discussed that we should ask few questions to the customer before designing the mold. Is it clear?
Yes.
Before start the designing. So this is very important. Is it clear? Okay. So now for example, we have a component here Okay, so where will be the gate location? See, this will be the gate location, right? This
Correct.
and this, right? This will be the gate location, and for this component, these two component, we have to use fan gate. Okay, so where we can use the air vent? At this position, at this position, and at this position, right? I can
Yes,
use.
sir.
Okay, so
Why don't we
here,
select the corner?
yes, yes. Tell me, we
Why don't we select at the corner, sir?
at this corner.
Yes, sir. Yes, sir.
We can use, but there is a difficulty of machining, right? Right.
Oh, okay, got it.
Yeah. So we can use. So basically, we have to design the air vent here. Is it clear?
Yes.
So we can design. Okay. So for example, material is PP. So basically, primary vent we can take 20 micron.
Yes.
20 micron, but it should be at cavity side. Okay, so so still I have not prepared the core and cavity right now. So basically I have just prepared the complete mold base. Is it clear?
Yes, sir.
Understood?
Yes.
Okay, so here in this lecture we have covered the complete mold base with the guide pillar and the guide bush and the air vent.
Yeah,
है ना?
okay.
And the air vents. So once you complete the multi-cavity mold design, so you have to provide, है ना? This is your homework, like, huh? This is your homework that you have to provide the air vent and you have to design the complete mold because I have not designed the completely right now. Okay, just for example, here you can see that this is the only one pressure pad here. Okay, so you have to provide the pressure pad here, here, and here also, right? Okay,
Yes, sir.
understood? And
Yes,
you
sir.
have to prepare the core and cavity also. Okay, and after the complete selection, after the complete design of the runner, okay, you have to provide complete things of the core and cavity. You can say that, right? Understood?